Hello, we are in our last objective from section 3.2, and this is going to be about integrating vector valued functions. Alright, so just like derivatives, our integral of vector valued functions would be integrating each of the components of your function, whether it be an indefinite integral or a definite integral. It's going to be the same process. Just remember that for your indefinite integral, each of these integrals will have a plus c attached to it. So we can put the plus c's inside of each of these components, or we can just remember to add a plus c vector on the outside. And we'll take a look at both of those scenarios. So let's take a look at this first example. We are integrating this vector valued function with respect to t. And so this is an indefinite integral, so we will have that arbitrary constant coming out. So our result here would be the antiderivative of each of these things. So I believe this is going to be t cubed over 3 divided by, t cubed over 3 times 3, so that's just t cubed. And here it's just t squared over 2 times 2, so that's just t squared. And that's the first component. Now, if we add an arbitrary constant, I'll be adding 3 constants, so I'll put subscripts in this. So the first one would be c1. This is a comma. And our second antiderivative is going to be 3/2 t squared minus 6t, and then you throw the constant. There's a plus c here, and it's a different constant from the first. And then finally, this is going to be to the fourth, so 6/4 t to the fourth. We could simplify that. Plus 5/3 t cubed minus 4t. And then here you have another c. Okay, now we could do this with the 3 different c's, or we can have our t cubed minus t squared, comma 3/2 t squared minus 6t, comma, let's call this 3/2 t to the fourth plus 5/3 t cubed minus 4t. And then we can imagine just adding a c, but a vector c that would have 3 components. So we can say c vector is actually going to equal to c1, c2, c3. And then that can take care of all those arbitrary constants. So we can approach it anyway that might be convenient. So I'll mainly be doing this first way, where we add it component by component, but you can also do it the other way. Our next problem here has a cross product. Now, there are no rules for cross products like derivatives. So derivative, we have a product rule, but when we have a product for an integral, it has to be a special case to be able to undo the product rule for the integral. So we don't have anything special. In this case, we would need to do the cross product first. So let's compute the cross product. So in an ijk matrix, you have t squared, t cubed, and then t cubed, t squared, and then t. Okay, so in I direction, we're going to get t to the third minus t to the, that would be adding t to the fifth, comma, the middle term will be a negative, and so it'll just undo the negative sign. That's t squared minus t to the sixth, and then our last term is going to be t to the third minus t to the third minus t to the fifth. So same as the first one. Okay, so let's integrate that. Let's call this t to the 6 minus t squared, just so we don't have that extra negative sign on the outside. So we integrate that, we will get, for the first component, I'll get 1/4 t to the fourth minus 1/6 t to the sixth, comma, and then I'll have 1/7 t to the seventh, and then minus 1/3 t to the third, and then the last one should be the same as the first one, and I'll put a plus c at the end, and just making sure that this is a vector plus c. Okay, so that's the deal with our indefinite integrals. Our next problem, our last problem, is going to be a definite integral problem, and so that would just entail you putting in the values for your limits in your integration. So on our first one, let's find the integral of this. Integral of sine, we have to do a u substitution, and then we'll come up with a 1/2 coming out, and the antiderivative of sine is negative cosine, so the 1/2 negative cosine 2t, and I won't put a plus c because we're doing a definite integral. And then our next is going to be the tangent t. The antiderivative tangent is, if you remember, it's ln of secant squared. And I believe it's just secant, so it's ln of secant. I think it's like negative on the outside and then ln of cosine, but we can write it as ln of secant x. Again, no plus c. And then this last one has a negative sign, but then you'll have a negative after u substitution, a negative 1/2. So 1/2, and then e to the negative 2t. So both of these use a u sub, and then this is just the formula for the tangent, which is ln of secant. Now we're going to need to evaluate this from 0 to pi over 3. We can do that component by component, or you can just put pi over 3 in and then subtract the vector when you put 0 in. So we will get a negative 1/2, and this is going to be cosine of 2 pi over 3, comma, ln of secant of pi over 3. And then we have a 1/2 e to the negative 2 pi over 3. And then we'll subtract what happens when we get 0. So the cosine of 0 is 1, and we just get a negative 1/2. Secant is 1 over cosine, so this is ln of 1. So cosine of 0 is 1, and secant is 1 over cosine, so that's going to be 1 over 1, and then ln of 1 is 0. And then the last one is going to be making that to be positive 1 as well, so this is going to be 1/2. Alright, I suppose we can finish this off. Cosine of 2/3 is going to be in the reference angle is cosine of 1/3. Reference angle is pi over 3, sorry. Cosine of pi over 3 is 1/2, and put that in the second quadrant. The cosine is negative, so that's a negative 1/2. So negative 1/2 times negative 1/2 is negative 1/4. I'm sorry, positive 1/4 because they're both negative. And then we have a minus 1/2 minus negative 1/2 from the second component. Now cosine of pi over 3 again is 1/2. The reciprocal is 2, so this is going to be ln of 2. And then minus 0. And then we have something that we can't really simplify anymore. So e to the negative 2 pi over 3 is just going to be that multiplied by 1/2, and then we subtract 1/2. So that's it. This is going to be 1/2. This is going to be 1/2 plus 1/4. There is 3/4, comma ln of 2, comma, and then you can take out a 1/2 if you want. And then this is e to the negative 2 pi over 3 minus 1. All right, so that is your result from this definite integral where we put in the limits. Okay, I hope that helps. Good luck.